Notes for 11.4, I guess it's Monday the 9th. We're going to be finding volumes of prisms. Remember, those have two parallel bases. They're always the non-rectangles, unless it's a box. And our cylinders, which have two parallel bases that are always circles. We're going to be finding the volume of these guys. So at the top of page 13 is where our notes start. And it says that volume is the space that a figure occupies. I like to think of it as being like if you filled it up with water, how much water it can contain. So we're going to be inside these figures. We've been on the surface area of them. Now we're going to be filling them up instead of wrapping them with wrapping paper. I don't really care about this volume of a cube thing because it's going to fall out naturally. So you don't even need to fill in that blank there. All right, so we're going to be finding the volume of a prism or cylinder, and to do that you need to know its height. So we've been working on the surface. We've always been sort of not using the height when they give it to us. Sometimes we've had to use it to find the lateral edge with the Pythagorean theorem, but now you're actually going to use it in the formula. So height's going to be in there, the distance between the two parallel bases, and we also need the area. I really don't care about this next part in your notes either. I want you to go to the next page where it talks about the formula. So for any prism, whether it has a triangle on the base or a rectangle on the base, or like this guy, if you're watching the notes, I'm holding up a hexagonal prism. This one has a hexagon on the base. In your homework, there's one with an octagon on the base. There's one with a trapezoid on the base. All of them, you do the area of the base, so you should write that in on your notes. I'd also write it in on your note card and make sure you know that this capital B is area of the base. Which, actually, when it has a rectangle on the bottom, is length times width, but this formula holds regardless of what shape we put on the bottom. So usually when I ask kids at this level, I say, how do you get volume? They'll go length times width times height. I'm like, yes, of a box. But there's so many different shapes that they all have the same premise of you cover the bottom and then fill it up with the height. If it is a box, actually let's stop for a second, go to your note card, and let's put that one in on the far top right where it says volume of a prism. Go ahead and write V equals capital BH. And then you might want to even take an arrow all the way to the bottom of your note card where we wrote all those formulas for capital B. Can I steal yours, Avery? So she's got all her capital B formulas down here. You might want to kind of draw an arrow down the side and point over here so you know that you're going to be using those again today. So we are going to start. So if it is a rectangular prism, and we say, oh, we're going to do capital BH, go ahead and write that down. The area of the base down here is a rectangle. To get the area of a rectangle, we do length times we do length times width to get the area of the base. And then we pull it up with the height. Yep, so thank you. When we do that, here's the height, by the way. We're going to get 4,800, and we label this centimeters cubed because it's centimeters and centimeters and centimeters. And there's 3 dimensions. So the box is a little bit too easy. So we are going, and there's 3 of them in these notes. So we're actually going to go to the worksheet in a little bit and do a harder one. Yeah, Mark?
Something to note also is since it's multiplying, you need to throw it in.
In any order, yeah, and I think that's a question on the worksheet. It says, well, what if you let this one be the base instead of, I always let the bottom be the base, but remember, for the box, it doesn't matter. So then I would have done 20 times 10 and filled it up with a 24 height. So the order does not matter. So again, one more box, and then I'm bailing on the box because it's too easy. And we're going to go to the worksheet and do one of them on there. So our volume is capital BH. For the box, it doesn't matter which one you consider the base. It just tilts the box. Like a box of cereal laying on its side versus standing straight up has the same volume. I like to use the bottom. So on this one, just a nice 5 times 3 for the area of the base. Pull it up with the height. and we're going to get 60 feet cubed. The box is a little too easy. So what we're going to do is in these notes, there isn't really a harder kind of the kind I want to do. So you're going to go to your note packet. You're going to rip out page 36. It's the 11.4 worksheet. So right now we're going to the back of the packet. On page 36 is worksheet 11.4. Parts of that are your assignment. I'm not going to assign the whole thing. But the one I want to go to while you're ripping it out, go ahead and write due Tuesday, but I'll tell you what part of it's due. I want to go look at number 6, and we're going to do that one together. And it's going to be part of your homework anyway, so I'm just going to draw it here real quickly. Number 6 looks like this, and it's got some dimensions on it. So we have a 38 right here, and a 36 over here, a 20 over here, and it has a 24 up on top, and they're all in feet. Okay, I got that from you, right? Yep. All right, so the first thing you're going to do is, like I've been doing the whole chapter, I've said you've got to go ahead and write your formula down, because you'll notice your formula sheet's getting really filled up. So first you have to recognize that this is a prism, and that we're being asked volume. And then our formula is capital B, so it's really important that you know which one is the base. I'm going to go shade it in with my finger. And remember, for the prism, I'm going to shade in the one that's not a rectangle, unless it's a box, and then it doesn't matter. So what shape am I going to be going and highlighting with my fingertip here? The top is not the base, because it's a rectangle.
The base is the one that has whatever that is called.
This?
Yeah.
What is it called? Trapezoid. Yeah, so this would be called a trapezoidal prism. It just is. We shaded it in, but that's not the base. Alright? So that front face is the base. So somehow I have to remember how to, every other shape is a rectangle. And remember I said, for a prism it's a non-rectangles, unless it's a box, and then like we just said, it doesn't matter which one's the base. So on this one, you have to go to your formula sheet, and if I were you, I like to find capital B outside of my workflow. So I'm going to draw a little arrow there, and I'm going to go to the bottom of my note card, or maybe I have it memorized, how you get the area of a trapezoid. So I'm only focusing on this yellow face right here. It's a trapezoid. On your note card, it's going to say that you add the two bases. So I'm going to write that down. Once you're done, you multiply by the height of the trapezoid, which is a little confusing because there's an H over here too. This is height of the prism. This guy right here is height of the trapezoid. And then we cut it in half. All right. So Brody, which two pieces do you think are considered the bases of the trapezoid?
Two parallel ones.
Yes, thank you, and I like your definition. In this case, it is the ones that look like the bases, but sometimes if that trapezoid gets tilted, you still have to know it. Like this is a trapezoid as well, and these parallel ones are the bases. Good memory. So when I add those up, I'd go 24 plus 36. I'm going to multiply it by the height of the trapezoid, so I'm not looking at anything else except the distance between those parallel bases, which is 38. When I'm done doing that, and you can cut it in half. So I need a calculator person. This is going to be 60, I know that. And then somebody do 38 times 30. I can do that much in my head.
2,208.
What is it?
2,208.
For 38 times 30?
Yeah, I got one. 38 times 60.
Yeah, that's the end
I
product.
know, but I cut it in half already, so
1,140.
that sounds right.
Yeah.
All right,
Yeah.
1,000, thank you guys, 140, and this was in feet, so we label it feet cubed, but what's wrong with my answer?
It's only the base.
Exactly, so be careful, because the base is what you're going to be working for, and when you're done, you still need to multiply that, so those of you with the 1,140 for the area of this base, we still need to multiply it by the height of the prism. So remember, that's the distance between those parallel bases. It's not a 38, right? Brianna, what's the height of the prism? What do you guys think? 20. Yeah, this guy. So you have to take your 1,140, the area of the base, And then basically you're just layering a whole bunch of trapezoids on back and filling it up. So whatever 1,140 times 20 equals.
22.
Thank you, Ava. 22,000, right?
Yeah, 800.
800, and then that would be labeled B cubed. So be careful that when you're done with the base, don't forget you have to fill the thing up with the height. All right? So this is that question that Mark was talking about where it said above, if a different side of the rectangle prism was used as the base, does the volume change? And the answer is no, right? So now we're going to up the difficulty a little bit because we have these triangular prisms. I'm going to do this second one first because it's easier. So again, the prisms, the base is the non-rectangle. So for mine on this one over here, it's this right triangle, okay? And there's two parallel ones, like Brody said. There's another one in the back, right? And basically you're just layering a whole bunch of them until you fill it up. Your volume is still capital B, H, but capital B morphs throughout all of the prisms, which makes them the most difficult shape on the whole. On your whole purple note card, the prism's the worst to deal with because that base is always changing. So I did a rectangular base, we did a trapezoidal base. Now this is a triangle base. It's easier when it's a right triangle because the area of a right triangle, or any triangle, is a half of the triangle's base times the triangle's height, right? But for a right triangle, those are always these two layers. So, just 1 second. Let's see what I've got going here. Hello, this is Miss Lerud. He's absent today. Yeah, okay, bye. Yep. All right, so when I'm finding the, sorry if you're watching the video, I had a phone call. I would do for the triangle, half of the base of the triangle times the height of the triangle. We can do that in our head. So the area of the base of that triangle is 30 meters squared. We're good with that, right? So I just go back up here and I plug it in. But what's the height of the prism? Yep, Ronan? 5. Last hour they told me 10, and I said you've got different heights going on here. The 10 is the height of the triangle. The height of the prism is the distance between its parallel bases. So we'd have 150 square meters. That's best case scenario with a triangle. What was that? Yes, thank you. Cube. Thank you, thank you. It's good catch. So on this guy over here, again, your base is the non-rectangles unless it's a square. There's always 2 of them, and they're always parallel. So on this one, it is a triangle, and I can steal that back dimension off. So I'm shading in blue here the area of the base. But here's the problem. It's not a right triangle. It's an equilateral triangle. So I'm going to pull it out, and we have to dig into our memory of when we have an equilateral. Yeah, it's going to do, somebody just said in the back, if those of you listening, 30, 60, 90, and here's why. So let's see if your memories are good. Equilateral triangles have equal angles and equal sides. When you drop the height down, because the height's always perpendicular, see over on this guy, they gave me the perpendicular. So that's, I could just say the height was 10. This guy, though, ends up being a piece of a 30, 60. And so that height of that triangle isn't there. It's actually from here to here, right? So do you guys remember how you go from the short side?
4 to the square root of 3.
Yes. Multiply by the square root of 3. To get the hypotenuse, we double it. So to make things longer, we multiply. To get this long side, it's going to be 4 root 3. So I'm going to go put that on my picture. So don't lose track of the problem. Let's go over here. We have to find the area of the base, which is the triangle, which I will do in just a second. Pull it up with the height of the prism. All right. So what I need you guys to do on your calculators is we're going to go get that. Erase this. We're going to go get that capital B. Come on, eraser. There, I guess that didn't like that. So our base is going to be 1/2 of the base of the triangle. I'm drawing it in right now, which was 8, times the height of the triangle, which we just found. It was a little tricky because we needed stuff from another chapter. So let's go to the nearest tenths. I don't care if you round that. So just go ahead and do a half of 8 or 4 times 4 root 3 for me, somebody. 27
No,
point.
no, no, 277.
It can't be that big.
27.7.
27.7 for capital B. You're giving me the answer to the whole problem. I just need the area of the base first. So just so you can see where his answer's coming from, we're going to grab that area of the base, go put it in. We're not done with the problem. That's the biggest mistake with prisms, is kids get wrapped up in finding capital B, and then they move on to the next problem. You still have to fill it with the height of the prism. What's the height of the prism? 10. Awesome. The distance between you guys are great. So this would be 277 inches cubed for the volume of that. So those are our prisms. They're the worst shape. So now the easiest shape to work with is a cylinder. It still has the exact same formula, but we can modify it because capital B for a cylinder is always a circle. So although it still is capital BH, B won't change. So what do you think I'm going to replace this capital B with before I tell you to write it on your note card? What's the area of a circle? Pi times what'd you say in the back?
R squared.
Thank you. Pi r squared will cover the bottom, and then you'll still need to fill it in with the height, or fill it up with the height. So I would go to your note card, and in your second one down on the right, I wouldn't write capital BH for the cylinder, because capital B is always pi r squared. So I'm going to hold this up for just a second. So right here, in the second one down on the right, I'd write B equals pi r squared H. Alright? So, and I'll give you a second to do that. We actually have one formula today, capital BH. But for the cylinder, you don't have to worry about that shape changing. So we might as well just call it pi r squared H. So the cylinder's way easier to work with. Alright? So when it says the volume or surface area of a cylinder, like when you get those on your test next week, you're going to be going, oh great, the cylinder's nice. Because they can't really hide the radius on you. There it is right there, it's 3. Over here they tried to hide it by saying the whole way across was 2, but you're just going to cut it in half. Right? They can't hide the height on you either. On this one it's 8, and on this one it's 3. So you're never missing ingredients for cylinders. So let's write volume equals pi r squared H, that's our formula. It says in terms of pi, and just in case there's somebody watching this video, I've been drilling it, but into you guys, but sometimes if they're from another class or something, maybe they're absent. In terms of pi means I'm going to go put pi down, I'm going to go throw the radius in, I'm going to go throw the height of the cylinder in, but in terms of pi means leave this sucker in your answer and only do the rest of it on your calculator. And this one is just a nice 9 times 8, 72 pi. Thanks for being so awesome, guys. I know when I'm recording it's a little dry because I don't interact with you a whole lot, but I couldn't find a recording of this. Sometimes I steal other teachers, but I couldn't find one, so that one is done. You guys go do this one over here, okay? And when it does that dashed line on your worksheets or tests, or that means it's giving you the diameter. So in this one, your diameter is 2. Height is 3. Leave your answer in terms of pi, and then I'll tell you what your assignment is.
Can we go outside?
Oh. Are we good? So you do volume equals pi r squared, and then fill it with the height. On this one, make sure you use r of 1 because it gave you a diameter. The 3's outside of it, who cares? In terms of pi means don't touch the pi. Don't even need a calculator on this one. Volume is labeled in cubic units. How's that? Good? All right. So your assignment's going to be that worksheet 11.4. It's going to be the odds with a few evens. Because like you guys, if you didn't hear them, they said this is easy. It is. But I want to make sure that I give you enough variety of them. So the odds are good, except I need to add a triangle. So we're also going to do 4. And we did 6 already. And then one more even, number 22 I'm gonna add to it. So if you wanna cross off all the ones that aren't. So odds plus those 3 due tomorrow. You can see my basket's full from last hour. They pretty much all finished in class. I think all but 2. Alright, so you go ahead and turn it in when you're done if you want to. Also, before I leave you, elk time. Oops, I just erased that. It was 4, 6, and 22. Yep. Also, elk time tomorrow. We're going to make up quizzes if you missed them. And anyone with 2 or more assignments missing, I'm going to put me in there. So you might see yourself locked into my elk time. I'm going to do it during homeroom. Alright? Go ahead and have at it. Should be fairly straightforward. And I got to upload this recording.